All right, let's talk about big data. You hear the term data science everywhere, and it can sound super complicated, right? Well, today, we're going to pull back the curtain and show you the surprisingly simple math that makes it all work. Let's dive in. So let's start with a big one. How in the world can something as concrete as math help us predict the future? I mean, that sounds more like a job for a crystal ball, not a calculator. But as it turns out, math is pretty much the key to the whole thing.
You see, the secret is that data science isn't about magic at all. At its very core, it's just about finding patterns. That's it. And math? Well, math is just the language we use to describe those patterns, measure them, and then use them to make a really good guess about what's coming next. So, to get a handle on this language, we've got to start with the absolute basics, the building blocks. We'll begin with the simplest way we can possibly organize information. And it all begins with this idea of a set. Honestly, just think of it like a shopping bag. You've got a collection of stuff in there. An apple, milk, some bread. The order doesn't matter, and having 2 apples is, well, you still just have apples in your bag. This simple idea of just grouping things together is step 1 for everything else.
Okay, so a bag of stuff is one thing. But what's really interesting is how different things connect. And for that, we have a relation. Imagine you have one set of people and another set of cities. A relation just pairs them up, like connecting a person to the city they live in. See? We're not just listing things anymore. We're starting to build connections.
Now, relations can get a little messy. One person could be linked to multiple cities if they move around a lot, which makes predicting things tricky. We need stricter rules. And that brings us to one of the most powerful ideas in all of math, the function.
A function is just a special, super reliable kind of relation. Think of it like a perfect recipe. For every specific input you use, you are guaranteed to get exactly one specific output. Every single time you put in the ingredients for a chocolate cake, you get a chocolate cake. No surprises. That reliability is what makes predictions possible. And here's what that looks like in the wild. Check out this table. Every input in that X column maps to one and only one output in the Y column. If X is 1, Y is always 5. If X is 2, Y is always 6. That's a function, pure and simple.
Now, tables are great, but let's be honest, our brains love pictures. So how can we take these numbers, these points of data, and turn them into a visual, something that can show us a trend we can actually see?
So that's the big question, right? When we look at our data points, how do we describe the pattern that's hiding in there? Is there a simple shape we could use to kind of summarize the whole thing? And even better, predict where the next data point might show up?
Well, often, the best answer is the simplest one, a straight line. And this famous little equation, y equals mx plus c, is the recipe for any straight line you can imagine. The c just tells you where the line starts, and the m, that's the important part, is the slope. It's the number that tells you exactly how steep that trend is.
And calculating that slope is actually super easy. You just grab any 2 points on your line, you figure out how much the line goes up between them, that's the rise, and you divide it by how much it goes across, that's the run. Rise over run. That's it. It's one single number that tells you everything you need to know about the direction and steepness of your trend. Okay, this is where it all comes together. This is the moment of truth. We've taken our data, we've described it with a function, and we've drawn a trend line. But here's the million-dollar question every data scientist has to ask. Is our line actually any good? How well does our prediction match reality?
So let's get specific. Imagine we've drawn a line through our data and its equation is y equals 2x plus 2. Now, some of our original data points might be a little bit above this line, some might be a little bit below. So how can we measure the total amount of offness?
We do it with something called the sum squared error, or SSE. I know, the name sounds a little intense, but the idea is actually beautiful. All we're trying to do is add up all the errors, those little gaps between our actual data and our prediction line. The smaller that total number is, the better our line fits. Simple as that.
And here's the 3-step recipe for it. First, for every single one of your data points, you just measure the straight-up vertical distance to the line. That's your error. Second, you square that number. Squaring it does 2 really smart things. It makes all the errors positive, and it really penalizes the big misses. Finally, you just add up all those squared numbers.
So when we run that whole process for our data and our line, we measure every single error, square them all, and add them all up, we get this, 6. That's it. That one number, 6, tells us the total error of our model.
We now have a real, solid way to judge how good our prediction actually is.
And would you look at that? Just take a second and see what we've done. We started with the simple idea of just grouping things, we built up to a function, we used that to draw a trend line, and then we figured out a way to measure exactly how accurate it is. We literally just walked through the whole process of building a basic predictive model.
What all this shows is that the heart of data science isn't some scary, complex formula. It's these elegant, simple, and powerful building blocks. Which, of course, leaves us with one last really fun question. We used a straight line because our pattern was simple. But what happens when the data follows a curve? What then? Well, that's a story for another time.